Hello, chemistry. This is the voice of Mr. Anderson. Today we're going to go through some notes. Apparently you have already learned some things about chemistry since this is my first day with you. And it looks like we're going to go over chemical reactions and trying to write out balanced chemical equations from words. Now, I would suggest that as you go through this, you either have this printed off copy or you can write this neatly into your notebook. So that you can have your notes, because we are posting our notes as well. You may want to have your periodic table handy to have by you as well. And we're going to walk through and do some of these. So let's go ahead and get started. First part is just review. We're going to work on remembering how we write chemical formulas, okay? If you remember, there was a process that we went through to come up with formulas, and really it was to identify the differences between a covalent compound versus an ionic compound. And whenever we have to look at those two, we're really going to be kind of following different sets of rules. The covalent compounds, I think, are pretty easy because the prefix tells you the number you need for each one. So if we look at this first one, we know it's phosphorus. We find phosphorus on our periodic table. Okay, phosphorus is a P. There is no prefix, so we only need one of those. Hydride is the hydrogen. It's a trihydride, so it's an H3. So PH3 is our phosphorus trihydride. We can do our sulfur hexafluoride. Sulfur again, S. Okay. And hexa is a prefix meaning 6. It's a fluoride, so it's an F6. Okay, so it's pretty easy for us to come up with these. Let's try another one here. Now this one's got a prefix, so it's di-nitrogen. So we find nitrogen. So it's nitrogen with a 2. Tetra, that's a prefix meaning 4. Oxide, oxygen. Okay, so dinitrogen tetraoxide. And then finally we have our carbon monoxide. So carbon is just a C. Mono is a prefix meaning 1, so just CO. Okay, so there's going through and just doing the covalent compound practice. Let's kind of walk through and do some of these with the ionic compounds as well. Okay, ionic compounds, remember, are easy to tell because you're dealing with one metal and one non-metal. Remember, the electrons are being transferred across, so that's why we're setting these up this way. So I'm going to go ahead and start with our aluminum chloride. Okay, aluminum chloride. So aluminum over here is an Al. Okay, and we look to the aluminum and say, what is its charge? Now, I like to look at our charges this way. So if I find my aluminum, this is a +1, this is a +2, this is a +3, so aluminum is a +3. In some place on our periodic table, we should have the charges listed as well. So aluminum is a +3. Then we find our chlorine. Okay, chlorine is Cl. It's a -1. Okay, so it's a -1. This would be our even on argon. So this is -1, -2, -3. Okay, and that's how we kind of work between them. To balance this out, we're going to need to have 3 of those chlorines to 1 of those aluminums. So AlCl3. When we do the same thing here with our iron 3 oxide, iron is one of those ones that's a transition metal. Okay, it's trapped here in the middle, so it has multiple charge states. And in this case, iron should have a Roman numeral to tell us what its charge state is. It's a +3, so we're going to put Fe. Okay, oxide is O. We look at where oxygen is on the periodic table. These would be our -1s, so oxygen is a -2. And then we have to balance our charges. So if I have a +3 and a -2, I'm looking for a 6, so I need 2 of those and 3 of those. The easy way is, remember, we can just cross these down. Okay, so we're on to strontium nitrate. Strontium nitrate. So, strontium on our periodic table, okay, is in our second group here. So here's our strontium. It's in the +2 column. So strontium, Sr, is a +2. Now we're looking for that nitrate. Now notice it's an ATE ending, which means that this is a polyatomic ion. Should be on the back side of your green sheet. And I don't have my green sheet handy, but I do know that a nitrate is an NO3, and it's a -1 charge. So we're now balancing our charges. Remember, we're going to need multiple of those, so we're going to have a little 2 down there to make our strontium nitrate. Excuse me. Now we have our potassium phosphate. Potassium, again, we look at where potassium is. Potassium is in that first column. It's a +1 charge. So K. Then we find our phosphate. Again, 8 on the end tells us it's on the back of our green sheet, so it's a polyatomic ion. So PO4, it's a -3 charge. So now we just cross this, so it will be K3PO4. Okay, so that's how we go through and we kind of build names from formulas. Now remember that when we do our symbols, okay, some elements we just list them as a symbol. So like oxygen's going to be an O, but we have to be careful because some of these are what we call our diatomics. And the diatomics get a subscript of 2, and they are listed right here. I always like to mark those on my periodic table. So my diatomics are my hydrogen, okay, my nitrogen, my oxygen, fluorine, chlorine, bromine, iodine. Those are all diatomics. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And so then we see it's oxygen, so anytime you see oxygen by itself, it's got to be listed as O2. Now cobalt, on the other hand, cobalt is just a metal. Okay, cobalt is right here on our periodic table, so it's just going to be a CO. Potassium is just going to be a K. Nitrogen is going to be an N, but be careful because nitrogen needs to have a subscript of 2. So this is just listing out single elements on our that we could potentially see in writing formulas. Okay. Now as we go through, we've got some examples here that we're going to work with. Okay. So here's our writing formulas. Just do this here. Okay. So we're going to write some formulas. So we can see that we've got aluminum plus bromine is going to make aluminum bromine. So aluminum, just the Al, plus bromine, okay, Br, but be careful because that's one of those diatomics, so that's going to get a little 2 down there. Put our arrow, and then we're going to make our aluminum bromine. Now remember, aluminum's a +3 from our periodic table. Bromine, okay, is in that -1 column. So it's a -1. So this is going to be AlBr3. And now we go through and we do the balancing. So first step, okay, make our formulas, our words into formulas. Okay, once we have our words into formulas, then we do our balancing. Okay, now balancing this, I'm looking here at my bromine first. I see that I have 2 of them, but over here I have 3. Anytime I get to those 2 and 3 situations, I'm looking to make 6. So I'm going to put a 3 there, put a 2 there. Remember that the coefficient needs to go in front of the whole formula. Now, it does change the amount of aluminums, which now says that we have 2 aluminums, so we're going to have to put a 2 in front there. So, checking our work, we've got 2 aluminums, we've got 2 aluminums, we've got 6 bromine, we've got 6 bromine, we're balanced. Okay, let's look at another one. Here's another example. Okay, looks like we've got some sodium hydroxide. Okay, sodium is an Na. I know it's a +1 charge. Hydroxide is a polyatomic ion on our green sheet. It's a -1 charge, so that's an OH. So that's a good formula the way it sits. We're now going to add to that our copper 2. Remember, Roman numeral tells us that copper is a +2 charge. The nitrate is on the back. It's a polyatomic ion, so it's CuNO3. And this is a +2 -1, so we're going to need 2 of those. Okay, and then we go through and we're going to make a copper 2 hydroxide. Remember, hydroxide is a -1, so it's CuOH, but we're going to need 2 of those, plus some sodium, so +1 nitrate, NO3, -1. We don't need to do anything with that one. So I'm checking all my charges, making sure everything works, because all these were ionic. Now I'm going to balance it, and when I balance this one, I'm going to balance based upon the whole polyatomic ions. Like this NO3, I see that I have 2 groups of them. So I'm going to need to have 2 groups of those as well. Now, the 2 that I put here in front of the sodium is going to mean that I'm going to need to have 2 sodiums. So I'll put a 2 over here. But that OH now is 2 of those, but that's good because I needed 2 of them anyways, and I only need 1 of the copper. So now we're balanced. Okay? On to our next example. Okay? We've got some sodium solid. Oh, let's start working here. So the word solid is going to tell us some physical states of this. So we're going to add physical states in this as well. So I've got some solid potassium chlorate. Okay, chlorate is on the back side. It's the list of the polyatomic ions. So that's a green sheet one. Potassium is right here. It's in group 1, so we know that we're going to be K +1. ClO3, I believe. Here, let me grab my green sheet. All right, I just double checked on my green sheet, pulled it up, and it's ClO3 with a -1 charge. So chlorate is a -1. So KClO3, don't need to do anything different with that one. Now, it did say solid, so I'm going to put a little s down in parentheses here to give my state of this. So it's just another descriptive thing about a chemical equation. Now, it says reacts to form, okay, so this is where my arrow is going to come in, some solid potassium chloride, so KCl. Again, potassium is +1, chlorine is -1, so that's a good formula. And, oh, we should list this as a solid. And oxygen gas, so O. Remember, anytime we see oxygen, oxygen's a diatomic, so it needs to have a little subscript 2, and it's going to be a gas, so I'm going to put G in parentheses. Now, I've got my KClO3, which is a good formula. I've got a good formula here and a good formula here, so now I can go ahead and balance this. Now, again, with this one, it's a little tricky, but I'm going to look at the oxygens. I see 2 oxygens here, 3 oxygens here, so that's that combination that I need to make 6. So I'm going to put a 2 there and a 3 there. Now I can go back and I can balance my potassiums. So you can see that I need 2 potassiums. I'm going to need 2 chlorines. So by putting 2 there, I'm going to balance my potassiums and my chlorines. So good quality balanced equation. Remember, physical states can be added in to make sure that you are showing that that's information that you knew from the statement. Okay. Our last one that we're going to walk through here is some nitric acid. Okay, nitric acid is also called hydrogen nitrate. All right, so nitrate is NO3, and it's a -1 charge. Hydrogen is acting like a +1 charge in this situation, so hydrogen's the +1 charge, so it's HNO3. And they told us that it's aqueous, so I'm going to put an AQ to represent that aqueous solution. So there's my hydrogen nitrate or my nitric acid. Now it says is neutralized by, okay, so that means that we're going to be adding something to this to neutralize it, and it says lithium hydroxide. Now lithium is a +1 charge. Hydroxide we know is an OH from our green sheet. It's a -1 charge. So that's a good formula, but this was solid, so I'm going to make sure I put my little S down there for a solid. And then we'll see to form, okay, that's the arrow piece, liquid water, okay, water is H2O, and they said liquid. Now liquid is different than aqueous, okay? When you're a liquid, you're a pure substance, okay? So like water is a pure substance, but this aqueous nitric acid means that it's a solution that has water in it, okay? So difference between aqueous and liquid. Liquid is pure, aqueous means mixed with water. So we have this solution that we're adding this solid to. We're going to produce some more water in it, okay, and it looks like we're going to get some lithium nitrate. So lithium is that Li, it's a +1. The nitrate, if we remember again, is NO3, and it's a -1. So there's nothing that we need to do that, but it's going to be in its aqueous state, so I'm going to add my little designation aqueous on it. Now I'm going to look through and balance this, make sure that I've got everything set the way it should be. All right. So the NO3, there was one of them here, there's one of them there. I've got one lithium, I've got one lithium. Now, in this case, the OH and the H went together. That's what made my water, so that's that part of that neutralization process. So it looks like this is now a balanced chemical equation as well. So that takes you through your notes. So hopefully you have that in. You will be posting your notes as part of this assignment. The other parts of this assignment are going to be to do some of the work from the practice, and you can see that the practice sheet is right here. I think that you can either copy these into your notebook or we will get you a copy of them to work from. But you can see that we want to finish Part A today. So that's going to be what we want to do here. Part A is just on the first side, so we just want to make sure that we go through and do the first side today. So you've got some practice here where all you're doing, the structure's already set, and then you've got some where you're actually going to be taking the statements and working on those. So you have to do that. That's part of your assignment. And then the last thing that you have to do is take some notes from Chapter 8, it looks like Section 2. And that is on our types of reactions. So we're going to be taking more notes on types of reactions tomorrow, so it's good for you to go through and do a little pre-work. Got my book right here. So we're going to go through and do types of chemical reactions. That's our 8.2. Either read it online or in your book. Okay, so that's going to take you through that. And then, of course, we want to make sure that we have access to the Quest assignment. So make sure that you're up and have that open and that I've approved you in the class so you can start looking at that. All right, thank you, and we'll talk to you tomorrow.